Hey everybody. We spent the last few days working with the standard form of a linear equation. Tonight, we're going to go back and we're going to revisit all three forms of linear equations that we've seen and use them to model real-world situations. The first thing we need to do is figure out what's the right form for each situation, for each type of situation. Sometimes we are going to know the constant rate of change in a situation and the initial value, right? If we know what the situation is starting at, that's the same as knowing the y-intercept, and the rate of change is the slope. So when we have a situation like that, we are going to want to use slope-intercept form. Okay, so that's if we know how much the situation is changing by, and we know where it starts. Now, if we know the rate of change and one data pair that's not the starting point, a good form to use would be point slope, right? We know one point and we know the rate of change, which is the slope. So that's the one that's going to help us out the most there. Now, if we know two different data points, and we know that the rate of change is constant. So if we can assume that the rate of change is constant, we know 2 points. We can use those 2 points to find the slope, and then we can use one of them to actually write the equation. That would be another situation where we can use point slope. And then finally, if we have a situation where the sum of two variable quantities is constant, that is when we're going to want to use standard form. Right? Remember, standard form is ax plus by equals c, where a, b, and c are integers. So if we have two variable quantities here and they add together to make a constant number, c is always an integer, so that'll be constant, that's when we want to use standard form. So now we're going to take a look at some examples and we'll practice picking the right type of equation to model that situation. Example 1 says, as a student council treasurer, you prepare the budget for your class rafting trip. Each large raft costs $100 to rent, and each small raft costs $40 to rent. You have $1,600 to spend. Write an equation that models the possible combinations of small rafts and large rafts that you can rent. Now, in this situation, we don't really have an initial value, right? There's no real point in this situation where we know that we're starting. We also don't really have two data points. We don't really have any input or output values. But we do have two variable quantities here, right? We don't know how many small rafts we're going to get, and we don't know how many large rafts we're going to get. So this would be actually the type of situation where we would want to use standard form. It says each large raft costs $100 to rent. So it would cost $100 times the number of large rafts. We can use X to represent that. Each small raft costs $40 to rent. We can use Y to represent the number of small rafts, right? So 100X tells us how much total money we're going to spend on large rafts. 40Y, 40 times Y, tells us how much total money we're going to spend on small rafts. And if we add the cost of the large plus the cost of the small together, it has to equal 1,600 because that is how much we have to spend. So this equation right here is the best choice to model this type of situation. Let's take a look at example 2. From 1990 to 2001 in Boston, Massachusetts, the annual excess fuel in gallons per person consumed due to traffic delays increased by about 1.4 gallons per person each year. In 1995, each person consumed about 37 gallons of excess fuel. Write an equation that gives the annual excess fuel in gallons per person as a function of the number of years since 1990. How much excess fuel was consumed per person in 2001. So there's a lot going on here. So let's take the time to figure out what we got to do. We want to write an equation. We know we want to do that. And we want the annual excess fuel in gallons per person as a function of the number of years since 1990. So we know we're going to need to know the year, 1995, 37 gallons of excess fuel per person. And we also know that the amount increased by 1.4 gallons per person each year. So every year the amount is increasing by 1.4 gallons. So in this situation, I know my rate of change. I know my rate of change is 1.4 gallons per person each year. Every year it's going up by 1.4. I also have a data point from this information right here. So I know that my slope is m, is 1.4, and I know that my data point, and we're doing years since 1990, so I'm going to put 5 for the number of years, and the output for that is 37. After 5 years, the amount of excess fuel consumed is 37 gallons. So now that I have a slope and a point, I can write an equation. I can write this in point-slope form. I have y minus 37 equals 1.4 times x minus 5. And there's my equation. Now it says how much excess fuel was consumed per person in 2001. We can use this equation to do that. Y minus 37 equals 1.4. Now my years is going to actually be 11 here because we're doing years since 1990, so 2001 is 11 years after that. So I got 11 minus 5. So now I just need to simplify. 11 minus 5 is 6. So I have y minus 37 equals 1.4 times 6 is 8.4. And then I add 37 to both sides. And I get y equals 45.4. So 45.4 gallons per person is my answer in 2001. All right, let's take a look at our final example. A camp charges a registration fee and a daily amount. If the total bill for one camper was $338 for 12 days, and the total bill for another camper was $506 for 19 days, write an equation that should say gives the total cost as a function of the number of days. How much will the bill be for a camper who enrolls for 30 days? So first thing, let's underline what we're doing. We're writing an equation that gives the cost, gives the total cost as a function of the number of days. So we're going to need a few things. We need $338 for 12 days. We also need $506 for 19 days. Now, this problem is not giving me the rate of change. It's not telling me what the price per day is. So we're going to have to figure that out on our own. But we do know that at 12 days, the cost is $338. Now I'm putting the 12 first here, even though it comes second in the problem, because 12 is the input. The cost has to be the output in this situation, right? The number of days determines what the cost is. So here I have 2 points. Now, anytime I have 2 points, I can always find the slope. So I'm going to have to do 506 minus 338 over 19 minus 12. And that is going to give me 168 over 7. And if I simplify that, I get 24. So $24 per day is my rate of change, right? That's our M. So now I can pick either of these 2 points that we started with, and we can write the equation. I'm just going to use the smaller numbers. No reason. So I have y minus 338 equals 24 times x minus 12. Okay. So now I want to know what will the bill be for a camper who stays 30 days. So remember, days are the input and the cost is the output. So we're going to put 30 in for x. We'll do this over here. Y minus 338 equals 24 times 30 minus 12. So 30 minus 12 gives us 18. So we have to do 24 times 18, so y minus 338 equals 432. And we add 338 to both sides to solve for y, plus 338. And we get y equals $770. So the cost for somebody to attend for 30 days would be $770. That sounds expensive to me. I guess I don't know that much about summer camps. Anyway, that's our last example for tonight. You guys are done. Go ahead and finish up your notes, submit them through Canvas, and I will see you all tomorrow.